whining.
There's going to be a reason.
Okay? There's a reason for that. So here's what happens. We're going to start looking at finding all possible zeros in order to factor something. We're going to factor these polynomials using synthetic division, but we don't have a starting point. So what we want to do is we're going to use what's called this rational zero theorem. And the rational zero theorem tells you how to start with these types of problems. So if I'm looking at the function of f of x equals x cubed plus 2x squared minus 11x minus 12, that's a 4-term polynomial, third degree. Usually we would probably sit there and think, can I group them? I can't. Okay? It's not going to work. Do I just wait for everybody to walk by so we can stare at everybody? Okay? You can't. There won't be any way to factor this. So you have to use what's called this rational zero theorem. Now again, this is a lot of words for something that is very, very simple. What you do is you list all the possible factors of your constant. My constant here is negative 12. Oops, is negative 12. What are the factors of 12?
6, 2,
1, 2, 3, 4, 6, 12. Now, the constant's negative 12, do you agree? So it could be positive 1 times negative 12, negative 1 times positive 12. So what I do here is I'm going to put plus or minus in there. I'm going to do the same thing if it was just positive 12 as well, because it could be positive 1 times positive 12, negative 1 times negative 12. It could work either way. You okay with that?
Yes.
So you list out all the possible factors of the constant, and then you divide that by all the factors of the leading term's coefficient. What's the coefficient up front of the polynomial? 1. The coefficient here is 1, so what are the factors of 1?
1.
So it's basically plus or minus 1. Now, this comes into play a little bit more when that leading term coefficient is like a 4 or a 6. Then you can have fractional amounts. So what this is basically telling you is that you have, of all the zeros to try to factor this with, you have 1, 2, 3, 4, 5, 6, 12. Because you double it because you have plus or minus. There are 12 possible zeros. All you do then is you go through them one at a time to find them. Yes, sir?
So when we add the factors together and then make it negative?
Yeah, that's basically what you're doing. You just put them all together like that.
And what did you say about the culture?
What happens here is that there are, in this scenario here, there are 12 possible zeros. We know that there's only 3 that work. We just have to pick one and start using synthetic division to find it. And that's it.
How do you know?
Because there's 12 numbers with positives, and it's
No, but how do you know it's only 3 squared?
Yeah. It's the power of
Oh.
Third degree. That's
Wait,
it.
I'm confused. You say you divide it all by the leading coefficient. How do you divide them? Like, do you add them all
Oh,
together?
what's 1 divided by 1? 2 divided by 1. 3 divided by 1. What's going to happen later on is that this is not going to be just a 1. It could be a 2x cubed, which means it could be a plus or minus 1 and a 2. So you could have 1/2, 2 over 2, 3 over 2, 4 over 2, 6 over 2, 12 over 2. Where some of those cancel themselves out because what's 2 over 2? We already had that taken care of. What's 4 over 2? It's already taken care of. 6 over 2. See what I'm saying here?
Yeah.
So there's a possible an extra one thrown in there where it could be at 1/2. That's what we're getting at.
So you don't add them all together?
No, you're not adding them all together. What I'm doing here, when I was adding them together, I was saying how many possibles are there? Well, there's 1, 2, 3, 4, 5, 6, and I have all the negatives. 7, 8, 9, 10, 11, 12. That's all I'm doing.
So you just go through until you find the 3 that work?
That's it. You only have to do it because what happens here, if this is a third degree polynomial, what happens when you find a 0? What does the degree drop down to? Did you factor that usually?
Yeah.
Yeah. Let me show you. Let me just use this example.
Yeah.
So if I'm using just this example, and we have coefficients, we'll start with 1, synthetic divide, 1, 2, negative 11, and negative 12. If I start with 1, I go 1, 1, 3, 3, negative 9, and I know that's not going to work. Right?
Yes.
I erase it, and I try negative 1. 1, negative 1, 1, negative 1, negative 12, 12, and I found 1.
So
I have to do it multiple times.
Just multiple.
You just keep doing it until you find a 0.
Okay.
Now what happens is, let me get 1 second, Michael. What happens now, does everybody see how I found a 0?
Yes.
That means negative 1 is a 0, so what's its term?
X
X plus 1.
X plus 1, right? So I know then, move this out of the way. I know that I have a term at x plus 1, and this is x squared plus x minus 12. Could you factor that?
Yeah.
What do you get? 4 and negative 3.
So then you just found the other two.
Correct. You don't necessarily need to continue using synthetic division. If you want to, go for it. A lot of times, if you just remember that it drops a degree, you're going to get something that's factorable. Synthetic division is the shortcut way to start factoring. It's the easiest, most efficient way to do it. Mike?
So, say if negative 1 get north, you go to 2, and
Yep.
then negative 2.
Yep.
And then all those numbers, you go back.
You'll get to one. Yes, ma'am. Let me check.
So if, when you got to the whole x plus 1 times the original equation, and it didn't work out cleanly, like the f of x squared at the end, like, would you advise us to do quadratic formula, or just go back and try to find other zeros?
Well, you should. One of them should work out because you're listing out all the possible possible rational solutions that you're getting there. So they should work. If one of them doesn't work, then you just screw something up. You wrote it down wrong. It's usually what happens. Okay. Yes.
Why do you like fraction up there? You say like factors of the constant or factor of the leading coefficient.
Because that's the rule.
So what does that mean?
It tells you the possible zeros. Let me show you again. If I'm looking at this one here, if I'm looking at that function there, f of x is x cubed plus 14x squared plus 41x minus 56. My possible zeros for that problem would be all the factors of negative 56, 1, 2, 3 doesn't work, 4 does, 5, 6, 7, 8, and then 4, 14, 28, and 56. Those are all the factors of 56 with your signs. And then I divide that by all the factors of the leading coefficient.
And then you get zeros.
Those are the possible zeros. Then you just start checking. You start at 1 and go through it. Doesn't work, go to negative 1, go through it. Go to 2, go through it. Go to negative 2, go through it. What you're doing is you're using synthetic division because it is a simple, fast process.
Well, why would you try negative 2? Or wait, a negative 3. A negative 3.
Did I say negative 3?
No, but like, would you just keep 1, negative 1, 2, negative 2, 3, negative 3?
No, you pick, these are the zeros that could work. Negative 3 in this case doesn't work because 3 is not a factor of 56. That's where this comes from.
Alright, I thought you were just like, going on.
No. I'm going in order of the
Yeah.
I'm going in order of the possibles. Does that make sense? That's all we're doing here, guys.
So like, you're saying the possible ones are 1, 2, 4, 7.
Yep. And using synthetic division is a fast, efficient way to do that just by adding and multiplying. You're just looking for your zero. And once you do that, you know that it drops a degree, and then it's usually something you can
Do
factor.
you have to test every single one of them, or just until you get one?
Until you get to one that works. Once again, when you do this, if I'm looking at this, if I start at 1, 14, 41, and negative 56. When I do that with my synthetic division, I'll be darned, I got lucky and I got it on the first try. Sometimes that happens. Sometimes you're not going to get it until you get to 7. But synthetic division is fast. Okay?
Does the F go all the way to 56?
I doubt it.
No, because you have to.
Okay. So now you know that 1 is a 0, therefore what's its term? Okay. This becomes x squared, 15x, and 56. And you can probably factor that.
And then, so, 58, you want to find the zeros and
Yes, sir.
factor it?
Because you're going to be finding all possible zeros. And using this process, finds them. Okay? You start with the list of possibles and you're willing it down to the answers. Yes, ma'am?
So are we gonna get problems that are like to like the fifth term?
Eventually. And I've got an example of that towards the end, and I'll show you how that's going to work. So let's look at this one. Fancy, aren't I? What I want you to do is all I want you to do is list all of the possibles. List all of the possibles here. Okay? I don't want you to see when you work through it. We have 1, 2, 3, 5, 6, 10, 15, and 30. All over, sorry, plus or minus. All over plus or minus 1 and 2. We agree?
Yes.
Now, if you think about it, some of these are going to be duplicates of others. Like 2 over 2. 6 over 2. 10 over 2. 30 over 2. Those are duplicates, right?
Yes.
So the only ones you have to remember to rewrite out then would be the plus or minus 1/2, 3 halves, 5 halves, 15 halves. That's all. You rewrite the ones that are not duplicated. A lot of times people will leave it as all over 1, and then this will be your secondary list. Okay? What I want you to get in the habit of realizing is that sometimes one of your zeros that you solve with will have to be a fraction. Okay? That's all. Did I miss one? You kind of were pointing at it like I missed one.
Oh, you're fine.
Okay.
I was thinking about something.
Okay. Because you had that look of that I skipped one, and I'm like, I don't think I did.
My brother does this thing where he like math in the air, and I was trying to do that.
I can't do anything in the air.
Roundhouse kick in there.
I have a vertical of literally, I think it's 8 inches.
It's better than 6.
Honestly, it's probably not.
Every once in a while.
I barely get off the ground.
So let's see. Let's do this then. Let's actually do the problem where we're going to find all the real zeros of the function. Now here it's asking for real, so it's possible you might get an imaginary. If that's the case, we would stop. You wouldn't know that until you got to your quadratics if you had to. So we have f of x, the function of x is 2x cubed minus 5x squared minus 14x plus 8. When we start with this, what you want to do is list out your possibles, which means take all of the factors of 8 divided by all the possible factors of 2. So we do this, we have, let's see, plus or minus 1, 2, 4, 8, all over plus or minus 1, 2. Now, in this case, 2, 4, and 8 would all drop out over 2, correct?
Yes.
The only one you'd have to double check then would be
1/2.
plus or minus 1/2. Does that make sense?
Yeah.
Okay. So, does it matter which one you start with? Yes, ma'am.
So, is it basically just gonna be like the odd numbers? If there's like, if it's a 2 in the bottom, like it's gonna be all the
A lot of times, yeah. A lot of times, yes. Yes, sir.
Let us like actually write it out before we get from dividing those through.
You don't need to. I'm not really worried about that because a lot of times the fraction one isn't usually the first one you're going to find. It'll come up later on when you have if your 0 is 1/2, that means your term was 2x minus 1. Does that make sense?
Yeah.
That's where, Your 0 is 1/2. 2x minus 1. Add 1, divide by 2.
Does this mean you want us to go through the
Yeah.
Oh.
So you just start. Start with 1, 2, -5, -14, and 8. And over time, a lot of this quick addition and multiplication, you're going to be able to tell by the second or third one you do if you need to continue with that value, with that possible 0. And just give up and erase and start over. Okay? So you drop the 2. I mean, right away, I know it's not going to work because I'm at -17, and I need to get to the -8 to make that work. So I just erase it, and I start over. I start over.
Oh, I thought you just some more in.
Yeah, it comes in handy, doesn't it? Oh. Oh, looky, looky. So it took us 4 tries, but is synthetic division all that difficult that it's that big of a deal? No. Synthetic division's quick, it's painless. So if -2 is a 0, my term is x plus 2, and now I'm left with 2x squared minus 9x plus 4. So I could factor that further if I'd like. -8, -1. See, in this case, 1/2 would have been a 0. So at this point here, do you need to continue your factoring, or could you by now tell me what your zeros are just with leaving it like that?
Like that.
You can, or if you want to continue to write it out. Yes, ma'am.
I'm confused because like sometimes you just say like since it's -8, -1, you just put x minus 8, x minus 1. I'm confused on when you do that and when you do what you did now.
We do that when, oops, we do that when this is equal to 1. If it was x, like the last one we had what, x squared plus 15x plus 56. What times what is 56? You add together to get 15, 8 and 7. So it's just x plus 8, x plus 7. When your leading term coefficient's not equal to 1, you have to do the other methods. You group them or split middle term, however you want to do it. Okay? And that's where you get your zeros. Okay? Yes, sir.
So that synthetic division would work before?
Yes, it would have. And that's the other thing I was getting at also. At this point here, when you get to this part, you could continue synthetic division with where you left off if you wanted to. It will work as well. Well, you're up to, you've gone through 1, -1, 2, -2, so what's the next number to try? You would go with 4 right there, and you would continue. And it does the same thing. You continue with where you are at. Let me move this over and I'll show you. I can disregard that 0 because it's gone now. And if I start at 4, I have 2, 8, -1, -4, and I'm done. So then I would have been at x minus 4, which we already found. And this is 2x minus 1. Synthetic division factors.
So this just has to factor.
Yes, sir, it's another way to factor it. Synthetic division factors, guys.
That's just crazy.
It is. It's nice. It's easy. We didn't learn this before because there's a lot going on with synthetic division. There's a lot behind the scenes that you guys had to understand prior to it. Of why are these where are these I'm a Southern boy. I am a Southern, in case you didn't know.
Where are you from?
Virginia.
Oh.
I know.
Why would you end up here?
Why is it Illinois?
Because I was born in Virginia. I lived there for about 6 weeks. So I am a Southern belle. Did you like the hair flip? That was pretty slick, wasn't it? Yeah. All right. So what's nice? Yeah. here's what happens then, and this is where you were getting at earlier. Oh no, what do you do when you have a higher degree polynomial? Well, more or less is what you sounded like. Yeah, oh no, what do I do? I am afraid, I don't know what to say. So,
Wouldn't it be just easier because there's more of a way of finding it here?
yeah. And at this point here, we have x to the 5th minus 2x to the 4th plus 8x squared minus 13x plus 6. That's a whole lot of junk going on that I don't even want to attempt to even start with. But knowing I don't want to say the fun of knowing that how to find your rational zeros, I list out all of my possible factors of my constant. I don't know. It's 1, 2, 3, and 6, plus or minus, all divided by 1. So you start with plus or minus 1, 2, 3, and 6. And we're going to list out all the zeros of this. We're going to factor this fully using synthetic division. Gee, I wonder what number I'm going to start with. Okay. Now, I heard, Christian, you said something about having to do with the synthetic here. What did you have to put in? Got to put a placeholder in. Got to put a placeholder when you're using synthetic division because you're going in descending order like that. So you drop the 1, 1, negative 1, negative 1, negative 1, negative 1, 7, 7, negative 6, negative 6, 0. Hey! I know. It's like we're playing Pong. So we know that our first 0 is at 1, therefore my term starts with? Yeah. So we've gone through 1, and I've got my first term at x minus 1, so should I try now? Negative 1.
Wait, are we going to have more than...
Yes. What's that? Notice what I'm doing here is I'm reusing where we left off. I left off here because it's at a 0, so now I'm just going to start with negative 1 because that's the next possible 0 on my list. Yeah. Because we've already taken out the positive one, so now we're going to see if we can take out the negative one.
So this is the same thing, just as if we would have factored if I split the little.
Yes, sir. 1, negative 1, negative 2, 2, 1, negative 1, 6. Negative 6, not 0.
Wait, isn't this what
You
this
weren't supposed
was
to raise the
negative 2?
negative.
Wait, did I screw something up or no?
Negative, doesn't it? Never mind.
Yeah, you put down the wrong set of numbers.
No, I didn't.
1, negative 2, 0, 8, negative.
No, because I'm starting where I left off.
God, are you even listening?
Jeez Louise!
I'm not listening.
Well, then, don't make corrections. You don't know what's going on.
No, I'm messing with you. So negative 1 didn't work, right?
No.
All right. 2. 1, 2. 1, 2. 1, 2. 9. 18. That didn't work.
1, 2, 1, 2, 1, 2.
Negative 2.
You can
Like 3. Oh, this one's too crazy. All over the place.
Oh! Yay! We find out the 0 at
Negative 2.
negative 2. So we know right now we're up to x minus 1. What's
X
this?
plus 2.
X plus 2. Notice how I'm keeping a little tally with my terms here on the side?
Yes.
Okay, so at this point here, this is a cube term, right? Could you factor that by grouping if you wanted to try?
If you really want to.
I don't want to try. I like synthetic division. It's fun. I left off at negative 2. What should I start with now?
3.
3.
1.
Because this was a 0 now. Don't worry about it. Start off where I left off. 1, 3, 0, 0, 5. Not gonna work.
15.
Negative 3. 1, negative 3, negative 6, 18, 23. Not gonna work. 6. 1, 6, 3, 18, 23, not going.
Not today.
-6, this is our last option.
One.
-6.
It might not work, maybe not up to 5.
54.
Well, equals 3.
So here's what happens. You've gone through all your list of possible zeros. You factored out everything you could, so right now you're left with, what was it, x? X minus 1, x plus 2, and this was x cubed minus 3x squared plus 5x minus 3.
You just leave it?
And you're done, because all the possible zeros that you could find out of that were 1 and -2. There's no quadratic when it's a cubic.
Ooh.
Alright?
Yes.
Super hot.
Now, yes, ma'am.
Dolphin.
We started with x to the 5th here, we got to x to the 4th, now we're at x to the 3rd. We're just working our way down. Yes, sir.
Would that work if you would have stopped like right there and then like factor that?
It might have. Now, the only thing that could possibly have gone wrong, the only thing that could possibly have gone wrong when it gets to the upper degree polynomials, and this is something that possibly could happen, is what happens if you have a parabola that touches it at one spot? Remember what that looked like as far as your terms? That was like x minus 3, x minus 3, x squared minus 6x plus 9. Is it totally possible that a 0 could be duplicated? Yeah. It could be. So could you have maybe have gone back to 1?
Are you kidding? No.
No, or you could just not.
What?
And you had another, you had a duplicate 0 at 1. Well, here's the thing.
Wait, do you have to listen?
No, well, hold on, watch what happens. Does everybody agree I'm at here where I'm at x squared minus 2x plus 3 then?
Yes.
This is, and we'll talk more about this scenario tomorrow. I just wanted to get you guys in the habit of this. Yeah, there is the possibility, when you get down to some of these, you get duplicated zeros. If you have duplicated zeros, you might have to go back and reuse the ones you started with. Yes, sir?
Oh, so when we are factoring with that, do you want us to just automatically go back to using this right away?
It wouldn't be, well, like I said, I just wanted to show you where we're going towards with it. Tomorrow I'm going to bring in why you got to do that.
So then we'll
Okay.
have to remember.
No, not tonight. I just wanted to get you that, because now here you can factor that. It's,
Because 3 times, what?
wait,
You can't do it because it's positive.
oh, that's right, positive, so.
You can't do it.
Oh. That was really scary. Did you guys see like black
Did.
pop up?
So, yes, sir.
But I mean, if you would like stop, like you said that they divided it once, and then you like minus 1 and then parentheses like whatever that you got, but you still get -3 like 0 and that, and
This one here, if you would have stopped, or if you would have restarted with 1 again.
if you would have just stopped and put like x minus 1 and then that like the like x to the 4th like all of the parentheses would be done.
You would have gotten to it eventually, because you, in all honesty, if you wanted to stop each time and relist your possible zeros, that works as well. It's just, as you get going on these things, and I'm just going to get you guys started on some real light ones, to be honest with you. We'll get into the weird scenario stuff more tomorrow. It's all the same process. So what I want you to do tonight is on section 6.6, it's page...
You abbreviate to alter, do you P? I really need to. What would be? Really?
Yeah, you can do PP.
Yeah.
I just understand where E is shorter.
All right, do those, please. All right. That is a really big hawk up on the light pole.
Oh, God. Oh, my God.
It looks like it's looking for a goose.
There was one in my front yard earlier, and then I saw it fly away with the squirrel in its mouth.
Oh, I didn't think. That's huge.
Fly away!